Hello everyone. Today we are going to talk about the insanely fast Whisper, which is another variant of the OpenAI Whisper model for speech to text or voice to text transcription tool basically. So the beauty of this tool is that this is a command line tool, but you can also run it from Python. In the previous videos we discussed two other variants, but both of them we utilized them from within Python. So this is a special kind of tool that we are considering today, and as the name implies, it's really fast. So let's have a look at it. My name is Rami Kushaba and I'll be your presenter for today. So let's start. So in the previous videos, we talked about the Whisper S2T, which support multiple backends like CTranslate 2, Hugging Face, and the original OpenAI. And then we also discovered and talked about the faster Whisper version. But today we are going to talk about a command line tool rather than a tool specifically like you can call from Python. So the beauty of this tool is that, as the name implies, again, it's really fast, it's powered by transformers, optimum, and flash attention, and it's a tool that you can easily run on your machine. In fact, the whole installation process doesn't take like more than a couple of minutes actually. So the way to install this specific command line tool is through pipex. So unlike the previous tools that we have installed using pip, and we have created virtual environment ourselves, by the use of pipex, you can actually install the actual command line tool inside a virtual environment straight away by using this one command. So pipex is a tool for installing and managing Python applications in isolated environments. So this is often the recommended option when you need to install command line tools, basically to avoid cluttering your system global Python environment. So pipex creates virtual environments for each of the tools that you install using pipex, and we are going to see how that works for us today. So one thing to keep in mind, because I'm running on Windows, so on the original GitHub repo of the pipex, of the insanely fast Whisper tool, they mentioned that there is an error on Windows related to Torch not compiled with CUDA enabled error, and they don't know yet the source of the problem or what is the root cause for it, but we do have a solution which is posted on their website. But I also provide another variant of that solution by using pipex run pip. So basically this is the command pipex, and then you say run pip on this specific virtual environment, which is insanely fast Whisper, and then you install Torch, Torch Audio, and Torch Vision inside that specific virtual environment, and you should be up and running. So in the remaining part of this video, we will go to the command line, we will install the tool, and transcribe with a few options. So let's actually go there and start testing. So to start the installation process, we went to the GitHub repo of the insanely fast Whisper, and this is exactly what the repo is called. So we go down to the instructions. So it says all what you need to do is to run pipex install insanely fast Whisper and the version. And if you go down further, there are some benchmark results and then some further instructions on how to install with either pip or brew. So you can install pipex through pip install pipex, or you can go brew install pipex. So what I'm going to do, I'm going to start an Anaconda prompt. Basically, I'm going to say pip install pipex, and that's the first thing to do, is that to have the actual pipex tool. So previously I've installed it, and you can see that on my laptop it says the requirements already satisfied, and then it installed the pipex because I have all the requirements. Now the next part of the installation process is for us to go down and have a look at the actual command through which we can install this insanely fast Whisper. And this is the command. All what you need to do is pipex install insanely fast Whisper. Now let the process continue, and we will come back to you when this is ready. So the tool took a couple of minutes to install, and that's it. We are up and running. So we have now the insanely fast Whisper on our system. And to test that, let's just say insanely fast Whisper. Oops, it's not typing. Now it's typing insanely fast whisper. I should see something instead of saying unrecognized. So if I see an outcome, there you go. The tool is available. The only thing it's saying is that there is an error because I didn't provide any argument. So there are a number of arguments that we need to go through. And for that specifically, I'm going to say -h, which means help. Tell me a little bit more about what these arguments are so we can start specifying them. So examples over here include, first of all, you need to specify which file are you going to transcribe. This is the audio file name, your MP3 or WAV or whatever extension. Then the device ID, which basically tells you about the CUDA or CPU. And then transcript path, basically, path to save the transcription output. The model name, out of which by default, the insanely fast whisper utilizes OpenAI Whisper Large v3. However, because I'm running on a laptop, it's nearly impossible for me to get this model up and running because of the huge memory requirements. So this model by itself is like few gigs worth of like memory, and that's very hard for my laptop to handle. So I'll go with something like the small or the medium, or even like medium English, which is focused on the English language only. And then the task, like, are you going to transcribe or translate the language of the audio, the input audio, the batch size parameter that we have mentioned in a previous video, where we said the batch size is related to the number of audio segments that you can process at the same time to increase the speed. And then the flash attention option, if you have that installed, and further details like the piano.audio, basically token, which you can get from Hugging Face, and the number of speakers, where you can specify the minimum and the maximum number of speakers. So to test the tool currently, we can go and start transcribing. So I have a file on my C drive in my temp folder, and this specific file I downloaded from YouTube. It's a video by Mike Cohen, so I'm going to transcribe this. It's around 42 minutes worth of audio, and I'm going to attempt to basically transcribe this file. So file name is c/temp/ this is where the file is, and then I'm going to specify the model name, and I'm going to say don't need codes, I need to say OpenAI whisper-small.en. So this should get me up and running if everything is installed properly. So the whole installation process was very quick. Now let's verify that we have it running. So you can see over here, because I'm running on Windows, we got the assertion error that I mentioned previously, and we said to overcome this error, you need to run this command, which is a command to install basically Torch Audio, and Torch Vision with CUDA support. So all what you need to do is copy the command, okay, go back to the command line, and then paste it and run it. And let it run, and we'll get back to you when this is ready. So now the tool has finished installing everything required, and we are ready to run the process. So now we are ready to test the tool after we have installed everything. So we go back to the command pipx run pip insanely fast whisper, which will be with the file name -- file name. This is where the file is located, the URL, and the model name, which is small.english at the end. So this should go forward now. So it's starting transcribing. Remember, the file that I've specified is actually 42 minutes and 16 seconds worth of audio. So it actually transcribed successfully, and it finished the process of transcribing in 10 seconds only. And the output is provided as a JSON file, output.json, and it's available at C, users, and my account name. So if I go to C, users, my account, output.json file, and there you go. So you can see the output is provided over here for each of the segments or chunks. It says the starting time, where it started, where it finished, and the actual text. So chapter 19, data communication. If we want to do quick verification, what we are going to do, go back to the audio file that was located in the temp folder. And this is Modern Statistics by
Chapter 19, Data Communication. Section 19.1, what is data communication? Well, this is an easy question to answer. Data communication is the communication...
So as you saw, the transcription is pretty much accurate because the audio is very clear. So that was it, actually, no more than this. So the whole process was very simple. We installed the tool, we installed the missing dependency on Torch and CUDA, and that's it. The tool is up and running. So now what we can do, we can try different versions of the model. So instead of small, I can go say medium. So let's see how much time does the medium model take. So I've previously downloaded this, not sure if it's going to download again. Now it's actually, it has it in my system, so it's straight away transcribing. So using the medium model, which should be a little bit more complicated or more, let's say, computationally heavy in terms of the model size and number of parameters, but it should be more accurate as well. So right now it's transcribing and it finished in 18 seconds. So the whole reason, like the only reason why would you go from small to medium is when you transcribe a file and you see inaccuracy in the actual transcription, and that's where you go increase the complication by bringing more complicated model, more parameters, and thereby having more accuracy. So you can go up more. So I can try, for example, the medium with no English, just medium. This should be maybe more complicated as well, and we'll download it if it's not there. It's downloading some files. This one is 3 gigs worth of data. So downloading this, and we'll show you the transcription once this is like ready, finished. So the download has finished right now, and it's going to start the transcription process very soon. Let's see how much time will it take with the medium. So with the medium.en English, took around 18 seconds to transcribe this specific file. And for the same file with the medium model, let's see how much time this is going to take. So we already crossed the 18 seconds and it's still going up. There you go, 23 seconds. Look, overall, the performance of Insanely Fast Whisper is literally insane. I haven't seen anything so fast from all the other models that I've tried personally. This is the fastest one indeed, and that's why they call it Insanely Fast Whisper. So now if I go back, let's say, to the small.en version, let's run this again. And then what I'm going to do, I have some virtual environments created previously, which contains the Whisper S2T and the faster Whisper. I'm really interested to benchmark against the other Whisper variants to see which one is the faster one. So right now, again, we run the transcription process again using Insanely Fast Whisper on the file with the small.en model, and we got the transcription within 9 seconds. So what I'm going to do, I'm going to the Anaconda prompt. Okay, remember the 9 seconds with small.en. So now let me do conda in list to see what other models do I have. So I'll say conda activate, give me the Whisper S2T. Okay, we are inside the Whisper S2T, and the file is located in cd/temp, okay, which is this specific folder. I have a function over here that I've written previously. What this function does, it imports Whisper S2T, imports a couple of other parameters. We are actually running Whisper S2T in a process inside a process, so that the utilization of the CUDA engine could be like, let's say, released after the model has finished the process. We are transcribing using CUDA, integer 8, batch size of 5. Instead of the medium.en, I'm going to say give me the small model, and this is using a backend of OpenAI. So if you haven't watched my other video about Whisper S2T, we actually describe the Whisper S2T as it has the ability to support multiple backends. So it can support CTranslate 2, OpenAI, and a couple other options over there. So now we're saying OpenAI small.en, and let's save it, and let's run the code and see how much time will this take, because I have a time over here, time.time, for the transcription portion, and then I print the actual time. So let's just say Python what was the function called again? So it was called call whisper s2t. Call whisper s2t. This should be the one. So because I've previously downloaded that model, let's see, call whisper s2t. What did I say? Python, oh, without the py, sorry. This should run now. There you go, it's gonna start running very soon. This is the ffmpeg that prints out the first time you run it. It's downloading actually the model, I don't have it, so it's downloading the small.en again for Whisper S2T in that specific virtual environment. Or the download command came from that virtual environment. So downloaded the model, and it's transcribed now for the same audio file with the same OpenAI model, which is the small.en. Let's see how much time the transcription process will take with the Whisper S2T. And Whisper S2T is really a good tool as well. It's pretty much fast when you run it from Python. But in comparison to the command line tool, the insanely fast Whisper, previously we reported 9 to 10 seconds with insanely fast Whisper, and now, oh, as you can see, 27 seconds it took us over here to run and acquire the transcription, to run Whisper S2T and acquire the transcription for the same audio file. And going back over here, we utilize a batch size of 5, integer 8 for compute type, and it's a CUDA. If I want to reduce this further, because we didn't check what was the batch size, let me just compare back with the insanely fast Whisper. So the insanely fast Whisper, there was a help command that I've utilized, if you remember. And let us just check what is the default batch size that we have utilized. So in here there is a batch size, reduce, default is 24. So the default batch size is 24. So what we really need to do is increase this, make it 24 for Whisper S2T to make the comparison fair, and rerun the code again. Let's see how much speed up do we get. So it's going to start any second, and this is all on my personal laptop with a GPU. The GPU type is NVIDIA GeForce RTX 4060. So it is actually, as you can see, it's utilizing the GPU heavily. Started over here. Let's see how much time will this take us overall with the batch size of 24. Process should be faster, but it should consume more memory. So a couple of seconds ago we said it took us around 20 something seconds with the Whisper S2T and a batch size of 5. Now a batch size of 24 and 50. It's actually worse for some reason, not sure why, but yeah, it's actually taken longer instead of to be faster, but at least it's shown it's releasing the memory at least. Anyway, going back to the topic of today, which is the insanely fast Whisper, did this in 9 to 10 seconds only. Now the question is, what if I go and make this even more complicated? So if I go say medium English, so medium English from OpenAI, run the process again in the virtual environment of Whisper S2T. Let's see how much time will it take us now on the medium, and then we will go back to the insanely fast Whisper, use the medium.en and see how much time does it take over there, just as a way to benchmark. Actually, in this case, I couldn't run it because I specified very large batch size, so CUDA out of memory. I can't do that. What I can do is I can go back here, okay, and say batch size of 1, reduce it to be able to run Whisper S2T again with the medium.en file, or the model, sorry, that we have selected. So waiting for this to see if we can run it. Let's check the memory of the GPU. It is actually being utilized heavily, but let's see if it passes or still complain about CUDA out of memory or something like that. It is going through, no problem, but it's terribly slower than the insanely fast Whisper, to be honest. But in comparison to the other models, like the faster Whisper and other models, we have seen the Whisper S2T to be really one of the good libraries. And it was like really doing like, transcriptions within very short time in comparison to other libraries, but not command line based libraries. So this is obviously, it's taken a long time. Interesting, 102 seconds. However, you know what? I'm suspecting that what if the fact that we are running the two of them at the same time and one of them is consuming memory, not letting the other one use it. So I'm gonna close the insanely fast Whisper, and you can see the memory dropped straight away over here. So it was actually keeping some memory because of the PyTorch actually retained the memory to maintain the context. So we have closed the insanely fast Whisper. I'm going to run the insanely fast Whisper again to get a decent figure about its performance with the medium.en model. So go again. Let's see if it's still going to be 102 or less. As you can see, again, it's 102 seconds, 0.8. Previously it was 102.6, so it didn't change much. So this was the benchmark of Whisper S2T for the same audio file that I'm transcribing over here, made of 42 minutes and 16 seconds of audio, using the OpenAI medium.english version. So now if I go back to have another command prompt, let's say again, let's run the insanely fast Whisper. Okay, let's say -- file name, which is something I got from c/temp / what was the file actually called? Modern statistics, modern something, and then -- model name, which we said would have been OpenAI Whisper - medium.english. Okay, let's see if this one, how much time will this one take from here? Because it's a command line tool, so it's available for us to run. It's transcribing in comparison to the 102 taken by the other model. Let's see how much time will this rerun based on the Whisper medium.en will take with the insanely fast Whisper tool. There you go, done. 18 seconds. So 18 seconds against 102. It is indeed insanely fast. And the transcription is available in a JSON file. You can calculate the word error rate that they call WER, and you can do your own benchmarking across several different files. But overall, the performance is amazing, to be honest. And yeah, it's beautiful. One more thing I wanted to add over here is that going back to this call Whisper S2T, we were actually benchmarking by using the OpenAI backend. So the comparison that I made by no means like it's meant to show that Whisper S2T is not as good as the insanely fast Whisper. Because if I easily switch this to C Translate 2 and keep everything else the same, we can rerun the experiment that we were doing basically. So transcribe the same file by just switching this backend to C Translate 2. You can see that it started downloading some files to do some tests. So you can see that by just switching to C Translate 2, we were able to transcribe the file in 47 seconds only. So now I'm going back over here. I'm going to switch to the small.en Save it and rerun the transcription process again with Whisper as Tutti. Let's see how much time is going to take us this time. This time, as you can see, it took around 24 seconds. So yeah, this is actually achieving something really good for us. So what else could you do over here? You can basically, again, you can say insanely fast Whisper and look at the further options. You can also transcribe a audio file with multiple speakers and like specify the number of minimum speakers and maximum speakers you expect in the audio file. However, you have to provide your token from Hugging Face. So you have to have a token over there. So I'm not going to run this option because I don't want to put my own token and show you the option running. But you can definitely do it yourself. It's so easy. Just get your token from Hugging Face and then plug it in and like specify the number of minimum speakers, maximum speakers, and you will get the transcription with that. So this was a quick benchmark and testing. It is indeed fast. So great job, guys, for those developers who made the tool. And yeah, that's about it. I hope you learned something new today over here. Thank you.